Find the first, second, and third derivative of the following function. So I have negative 9x plus 3 to the fourth power. And I need to find successive derivatives of this thing. So one thing that I notice is I have a function, which I'll call u. So I have an inner function. And that function is raised to an exponent. So I have an inner function and an outer function. So the outer function is the fourth power. The inner function is u. So the derivative of h here is going to be the derivative of the outer function times the derivative of the inner function. And that's how we work through with the chain rule. So simplifying here, just walking through the process, this would be 4 times negative 9x plus 3 to the third power times negative 9. And since we're going to do another derivative, it's a great idea to go ahead and simplify this. So 4 times negative 9 would be negative 36 times negative 9x plus 3 to the third power. Okay, in the next derivative here, we basically have the same setup. We have a function u, and it's being raised to the third power. The constant multipliers you can put off to the side. You don't have to worry about them until the end. And so effectively, we're doing the same process. I'm taking the outer function, u to the third, differentiating it. So I'll leave my inside function alone. Then multiply by the derivative of the inside function. So I left 36 off to the side. That's where this came from. And then I applied the chain rule to this part, which is the derivative of the outer function evaluated at the inner function times the derivative of the inner function. And again, simplifying here is probably a great idea because that's going to make it a little bit easier in the next stage. So let's see, I've got negative 36 times 3 times negative 9, a bunch of coefficients, which make up 972 here. So 972, negative 9x plus 3 to the second power. All right, then next here, the form is the same. So the process that we take to differentiate is the same as well. I'll leave the 972 off to the side, apply the chain rule to this remaining function. So the outer function is the square, so bring the 2 down and leave the inside part alone for now, then just subtract 1 from the exponent. Then multiply by the derivative of the inside, which is just negative 9. And let's go ahead and simplify since it's just multiplied coefficients. 972 times 2 times negative 9. And it's a pretty large coefficient, but that can happen when you have numbers multiplied repeatedly here. 17,496 negative 9x plus 3, and then this is to the first power. This is a perfectly fine answer. One thing that you could do to actually make it a little bit simpler is if you'll notice inside here, and since this is to the first power now, there is a common factor that could be pulled out of negative 3. So you could take negative 3 out of here and apply it to this one. So effectively, let's multiply that by negative 3. So 52,488. So we could say this is positive 52,488 times the quantity 3x minus 1. And that's completely equivalent to the previous answer. Just a little bit simpler of a form. Whatever you prefer is okay, because all you have to have is something that's algebraically equivalent to the derivative, and you're all set.